3.2 to 3.4, adding, subtracting fractions. I can add and subtract fractions.
Excellent. I can add and subtract fractions is hopefully what everyone's saying. I need all of your eyes up here. Fraction, numerator, denominator, all wonderful things. The second part of denominator we need to pay close attention to. The first thing we look at when adding, subtracting fractions is the
Denominator.
That's what this says. We always light up the denominator, as they say. Say, light up the denominator.
Light up the denominator.
Common denominators, same as finding common multiples. Do you have to, when finding a common denominator for 1/2 and 1/3 or any unlike denominators, do you have to do this anymore?
No.
This can be your scratch work. If you need to do it, it can be your scratch work. I'm not going to require you to show me that anymore. That was from last chapter in which we found or used that strategy to find least common multiples. All right, so number 6, we have 1/7 plus 3/7. Light up the denominators. What do we notice about the denominators?
They're the same.
They're the same. So if they're the same, we simply add the numerators, right?
Yes.
And we are done once you add the numerators. Never, ever, ever, when adding and subtracting fractions, add or subtract the denominators. Number 7, same thing. We have 9/12 minus 3/12. We got 6/12 as our answer, but is that our final?
No.
You must always reduce. Do I need to see your work when you're reducing?
No.
I don't need to see your work anymore. I don't need to see that. Number 8, 2/5 and 1/7. When you light up the denominators, when you light up the 5 and the 7, you notice that they are different. So if they're different, we must find a common
Denominator.
So you guys found 35. Is it necessary to make your bubbles?
Yes.
I will always require your bubbles. Once you make your bubbles, you fill in your numbers inside the bubbles. You establish your numerator of 14 and 5. Add them together. We got 19/35. It's not reducible. Good to go. Number 9 is another example, but with subtraction. Moving on to mixed numbers, adding and subtracting mixed numbers. Is it okay to find or to add and subtract mixed numbers before? I'm sorry, I'll take that back. What do you do when you have mixed numbers before you can do anything else? No, you don't look at the denominator. That's exactly what I don't want you to do. Remember, you can always need to be calculating with impropers. Excuse me. So we converted both of these into impropers, and then we lit up the denominators. What do you see here? They're the same. So we simply do our numerator math, and we're done. Yes, no?
Yes.
We're done after this? Can we answer in improper form?
No.
Answers always need to be converted back into mixed numbers. Okay, number 11 then. Number 11, when you look at the denominators, they're different. However, are we looking at the denominators first, or are we converting into impropers? What? Okay, I'm not getting everyone. I see some of you looking like not up here. Convert into impropers and then light up the denominators. When you light up the denominators, you got 5 and 4. Are they the same?
No.
No. So therefore, you have to get a common
Denominator.
or a common multiple, whatever you want to call it. Make your bubbles. Do your math in your bubbles. Establish your numerators. This was our final answer, yes or no?
No.
No. 8220 says not. It's improper, right? So we converted back into a mixed. Is that reduced? So we continued on and we reduced it all the way down to 4 and 10. Yes, no?
Yes.
Last example I have is number 12. I don't like when they're written vertical like this, so I just rewrote it horizontally. Make sure if you're going to do this, if you're going to rewrite it horizontally, that you don't change the problem. It's 6 4/5 minus 8 2/3. It needs to be written as 6 4/5 minus 8 2/3. When adding and subtracting fractions, you always do what with the denominators? That was a good question. You always look at what first when adding and subtracting fractions? Denominators. If you have mixed numbers, you convert them into impropers, and then you look at the denominator, right?
Yes.
Okay.